Let's take a look at the homework for day number 5. If you make it through this one, you're doing really well. There are 3 limiting reagent reactions, stoichiometry questions here. 3 of them, so that'll take a while. What I decided to do is I decided to figure out all the molar masses for all my chemicals first. So I went through, pulled out all the chemicals, and I've got them all here. Like this is for question 1, 2, 3, 4, 5, and 6. So I don't have to do this, stop and do those calculations in the middle. All right, so let's take a look at question number 1. We're going to take this reaction. NH3 plus O2 gives us NO plus H2O. All right, so we got to balance this guy here, right? N's are balanced, O's are balanced, H's aren't. We've got 3, we've got 2. That means we're going to have to try 3 here and 2 here. Then we need 2 of these guys. All right, so H's are balanced, N's are balanced. Let's talk about our O's. We've got 5 O's here, right? 3 here, 2 here, 5 O's here. So we put a 2.5 here. So we've got 2, 2.5, 2, and 3. Now to get our actual numbers, we've got to double those. 4, 5, 4, and 6. So what do we know? What are we trying to figure out? Well, we've got 3.2 grams of this, 3.25 grams of this guy, and 3.50 grams of this guy. And so we're going to have to figure out which one's limiting. How many grams of NO is formed? So we're trying to figure out how many grams of NO form and how much excess reactant remains. All right, so let's get this guy started. So we need to do both of our reactants. So we're starting off with our mass of NH3. We're going to go to our moles of NH3. Right, and it is 3.25. And over here, we're going to do our mass of O2. Heck, I should do this in red so that we're going to go to moles of O2. And we start off here with 3.50. All right, so I've got my molar mass conversions here. So how many moles of NH3 are there in 3.25 grams? If 1 mole contains 17.031 grams. So 3.25 divided by 17.031. We've got moles of 0.19083. 5 sig figs, but our answer should only have 3. Let's do our O2. So how many moles of O2 will there be in 3.50 grams if 1 mole has 31.998 grams? So 3.50 divided by 31.998. 0.10. 10938 to 5 significant figures. Keep a couple there. Now, here's where we do our pretend. We're going to do our pretend, right? These are actual amounts that we have from the question. Now we're going to do our pretend. All NH3. And over here will be all O2. So in this one, we're going to start with our moles. NH3, 0.19083. We're going to go and we're going to figure out how many moles of O2 that would be. And we're going to use our molar ratio. Our molar ratio is 4 moles of NH4 to 5 moles of that. Over here, we're going to start with our moles of O2, which is 0.10938. Then we're going to go to our moles of NH3. And our molar ratio will be reversed, 5 to 4. Okay, so we're asking how many moles of O2? 0.19083 0.083 if it's 5 moles of O2 to every 4 moles of that. So I take my 0.19 times it by 5 is I times it by 4. Times it by 5. Then take that answer and divide it by 4. And we get, I'm going to put this in red because O2 is red, 0.23854. 5 significant figures. Now over here we're doing how many moles of NH3 are there will react with 0.10938 moles of O2 if the ratio is 4 moles of NH3 to every 5 moles of this. So you take my 0 point times it by 4 and divide it by 5, and I get a total of 0.08750. 5 significant figures. All right, now let's decide which one of these is real and which one of these doesn't work. So this one, we have this amount of NH3. Do we have this amount of O2? So this one works. This one does not work. So this guy means our NH3 is in excess. Right, because on this one, we have this much O2, and we definitely have this much NH3, so both of these work. So this means our O2 is limiting. Okay, so we're going to continue with the O2 track down to figure out our moles of, our grams of NO. So you got our moles of O2 that we're working with. 0.10938. We're going to go to our moles of NO using our molar ratio. Our molar ratio is 5 O2s to 4 NOs. Then we're going to go from our moles of NO to our mass of NO using our molar mass. Now the beautiful thing is here, this molar ratio right here is the exact same as this molar ratio right here. So this number at the bottom is going to be this number, 0.087505. Now we can figure out how many grams of NO will there be in 0.087505 moles if there is 30.006 grams in 1 mole. So we take that 0.875 times by 30.006 to get a total of 2.63 grams. Oh, and I forgot to write that down. All right. Now, let's figure out our excess NH3. So remember, our excess is equal to our total amount. So our excess NH3 is equal to our total amount minus amount used. So our total amount of NH3 that we had in the chemical reaction was this. We had 0.19083 moles. And we used up this amount right here, 0.087505 moles. So we're going to take those two and subtract them. And we get 0.103 moles. It should have 3 significant figures because both of these guys should have 3 significant figures. That's how much excess NH3 there is. We could convert that to mass if we wanted to, but we got a number of these limiting reagent questions to go through, so let's not. So look at this again. right? Figured out the moles of both of our reactants, pretended that both of them were used up, see which one worked, which one didn't work, use the working one to figure out our last thing, find our excess. Right, there you go, limiting reagents. Question number 2. Consider this reaction. C6H6 plus Br2 gives us C6H5Br plus HBr. What is the theoretical yield if 42.16 grams of this, so 42.1 grams of this react with 73.0 grams of this, and we know our actual yield of this, so we're going to need to figure out our theoretical yield of that guy. Right. We don't need to do our excess reagent, but we have to see which one's limiting. And this one's easy because all of our molar ratios are 1-to-1, right? So there's no conversions there. That's pretty simple. So we're going to start off with our mass of C6H6. We're going to go to our moles of C6H6. We have 42.1 grams. Then over here, we're going to start with our mass of Br2. We're going to go to our moles of Br2. And this is 73.0 grams. All right, so let's do our C6H6. So how many moles of C6H6 are there in 42.1 grams? If 1 mole has 78.114 grams. So we take our 42.1 divided by our 78.114, 0.5386 to 5 sig figs. All right. Now this one, bromine, how many moles of Br2 in 73.0 grams? If every mole has 159.808, so 73.0 divided by 159.808, 0.4567, 80, that's rounded to 5 sig figs. I got the whole number in my calculator. All right, so now we're going to do our pretend, and this will be pretty easy. Pretend all C6H6 is used up. We're going to pretend that all Br2 is used up. So we're going to start with our moles of C6H6, which is 0.53896. We're going to go to our moles of Br2 that would be used for this, and since it's just a 1-to-1, it will be the same, 0.53896. Now, since we don't have to figure out the excess amount, we can just do one of these and see if it works. So let's check to see if this guy works. We have this. Good. Do we have this amount? No, we have less than this. So we don't have enough of this. So we cannot use up all of our C6H6. That means this guy over here, Br2, is limiting, and C6H6 is excess. So we're going to use our Br2 to continue on with the stoichiometry. So we know our moles of Br2, 0.45680 to 5 sig figs. We're going to go to our moles of what, C6H5Br, C6H5Br, and the molar ratio is 1-to-1, so that's going to be easy. Then we're going to go to our mass of C6H5Br. So 1 to 1, so this is going to be 0.45680. So then we can write up our last question. How many grams will we get in 0.45680 moles if there are 157.01 grams in 1 mole? So we take this 456.45680 times it by 157.01. And I did not get that. 157.01. 71.7 grams. Okay, there's that. Now, what is our percent yield if our actual yield is 63.6? So remember, percent yield is equal to our actual divided by our theoretical. Our actual was, 63.6? And our theoretical was 71.7 grams, both 3 significant figures, so our final answer should have 3 significant figures, though I'm using the whole number in my calculator. 63.6 divided by 71.7, 88.7, so 0.887, or 88.7%. There you go. That's question number 2 done. Not too bad. If you don't have to figure out the excess reagent, you can just check one of them, see if it works or not. If it works, it's your limiting. If it doesn't, it's your excess, and the other one is limiting. All right, question number 3. Oh, yay. 950 grams of copper 2 sulfate are reacted with 460 grams of zinc metal. What is the theoretical yield of copper? So we're going to have to write out this chemical reaction. So we've got copper 2 sulfate, CuSO4. That's a 2 plus charge, 2 minus charge, plus zinc. It's going to give us copper plus zinc SO4. Let's check our charge on zinc. Zinc, please be plus 2. Please be plus 2. It is plus 2, so right there it is. There's our chemical reaction. And guess what, boys and girls? It's balanced. Done. Molar ratios are easy. We know we've got 950 grams of this guy. And we've got 460.0 grams of this guy. Both 4 sig figs. We're trying to figure out our theoretical yield of copper so we can figure out our percent yield. So we're going to have to do this with limiting reagents. All right, so we need our moles, CuSO4, so our mass, CuSO4, 950.0 grams. We convert that into our moles, CuSO4. Then over here, we start with our mass of Zn. We go to our moles of Zn. And this is 460.0 grams. So how many moles are in 950.0 grams? If 1 mole has 159.608 grams. So we do our 950 divided by our 159.608. 5.9521. 5.9521 moles. 5 sig figs. This guy over here, how many moles in 460.0 grams? If 1 mole has 65.39 grams. So we do our 460 divided by 65.39. We get 7.0347. Okay. Now, because you don't have to worry about the excess amount, We just need to figure out which one's limiting. We only need to test one of them. So we're going to pretend all CuSO4. So we're going to pretend to use up all of our CuSO4. So to do that, we've got our moles of CuSO4. That's 5.9521. And we look at our moles of Cu, our moles of zinc that would react with that, and that would be 5.9521 because it's a 1-to-1 molar ratio. Now we see if this guy can work. If this guy works, then CuSO4 is limiting, and this guy's in excess. If it doesn't work, then this guy is limiting, and this guy is in excess. So we check. Do we have this much CuSO4? Yes, we do. Do we have this much? Right, this is our real amount. So we've got more than this. This guy works. So CuSO4 is limiting. So we can continue on with our CuSO4 side. So we're going to go with our moles of CuSO4. That is 5.9521. We're going to go to our moles of Cu. And this is a 1-to-1 molar ratio, so it's just the same number, so we can just write it down. Then we're going to go to our mass of Cu. To do that, we'd use our molar mass. How many grams Cu are there in 5.9521 moles? If in Cu there's 63.546 grams in 1 mole, so I take my 5.9 times it by 63.546, 378.2 grams. That's my theoretical. Now we're going to do our percent yield calculation. So percent yield is equal to our actual divided by our theoretical. From our question, our actual is 295.8 grams, divided by our theoretical of 378.2 grams. So I do 295.8 divided by my 378 answer, which is in my calculator still. And I get 0.782 to 3 significant figures, or 78.2%. There we go. That's question number 3. Limiting reagents. I like that this work takes up a lot of space, and it shows all that you're doing very easily. All right. Let's go to question number 4. Whew. Okay. Question number 4. We've got a chemical reaction right here. U plus 3Br2 gives us UBr6. What was my actual yield of hexabromide if I start with 100 grams of uranium and get a percent yield? So in this one, I've got 100 grams of this. We're going to pretend that's 3 sig figs. We can figure out how many grams of this. And then using our percent yield, we can find our actual yield. So we have to find our theoretical yield first. So let's write up our stoichiometry path for this. So we start with our mass of U, which is 100 grams. We're going to go to our moles of U. Then we're going to go from our moles of U to our moles of U, Br6. Using our molar ratio, which is 1-to-1. That's beautiful. We don't have to do any conversions there. Then we're going to go to our mass of UBr6. All right. First conversion. How many moles in 100 grams? If the 1 mole of uranium has 238.029. 238.029. So I do 100 divided by 238.029. 0.42012. to 5 sig figs. We're going to pretend this guy has 3 sig figs. We just copy that guy down since it's a 1-to-1 molar ratio, so we're going to get the same number of moles for this guy. Then we're going to do how many grams of UBr6 in 0.42012 moles if there are 717.453 grams in 1 mole. So we take that number, we times by 717.453. 301. It would be 301 grams. That's our theoretical amount. Now we can do our percent yield. It's equal to our actual divided by our theoretical. We know that our percent yield was 83%, so we can do 0.83. It's equal to our actual is what we don't know, and we divide it by our theoretical is 301 grams. So to figure out our actual, we just multiply those two numbers together. Times by 0.83, and it'll be 250 grams. To 2 significant figures, right? This guy has 3 sig figs, this guy has 2, so our answer should have 2. That's it. That's question number 4. Whew. Question number 5. All right. We've got H2SO4 yields us H2O plus SO3 if I start with 89 grams of sulfuric acid and I produce 71 grams of water. This is our actual amount, so we can figure out our theoretical. So we know 89 grams, and we're trying to figure out how many grams of that guy. Look at this, another 1-to-1 molar ratio, right? This is balanced, so that makes things a lot easier. So we're going to start with our mass of H2SO4 at 89 grams. We're going to go to our moles of H2SO4 using the molar mass. Then we're going to go to our moles of H2O. It's a 1-to-1, so I don't need to do any work. Then we're going to go to our mass of H2O using our molar mass. Start it off. How many moles are there in 89 grams of H2SO4 if 1 mole has 98.078? So 89 divided by 98.078. 0.90744. Right, this is 2 sig figs, so our final answer will probably have 2 sig figs. So 0.90744. Then we can do my next conversion. How many grams are there in 0.9744 moles of water? If there are... Oh, didn't I do H2O? Oh, come on. Oh, I've got it up there. If there's 18.015 grams in 1 mole, so we take that number and times it by our 18.015, we get 16 grams. This is our theoretical. So now we are going to do our percent yield. Percent yield is equal to actual divided by theoretical. Our actual is 7.1. That's 2 sig figs divided by the theoretical 16, which is 2 sig figs. But I use the whole number in my calculator, and I do 7.1 divided by that number that I just had. And I get 43%. 0.43 or 43%. There's question number 5. Once we got the first 3 done, these ones aren't so bad. Once you know limiting reagents and you do a full limiting reagents, then this isn't too bad. All right. Last one, we have to do a chemical reaction for it. An organic chemists react CH4 with Cl2 and got some CH3Cl and some H2. So let's put up a chemical reaction. So CH4, and it tells us that this guy's our limiting one, plus Cl2, This guy's our excess guy. We're going to get CH3Cl plus H2. Now we've got to balance this guy out. No, this sucks. Really, it does. Because our H's are the problem. C's are balanced. Cl's are not balanced. We need two of these guys. Then we need two of these guys. Now Cl's are balanced and C's are balanced. Good. Now let's count up our H's. I've got 8 H's here. I've got 8 H's here. Perfect. From the question, I know I've got 10.4 grams of this. And I'm trying to figure out my theoretical of this. Now look, this is a 1-to-1 molar ratio. So whenever we figure out the moles to this, we can just write them down to that. And so we're trying to figure out our theoretical here on this guy, because we've got our actual right here. So what should our theoretical yield be? All right, so let's map this out. So we're going for mass, CH4, 10.4 grams, to our moles of CH4. Then we're going to go to our moles of CH3Cl. Now this is a 2-to-2 molar ratio, which means it's just 1-to-1. Then we're going to go to our mass of CH3Cl. Good, so first step. How many moles are there in 10.4 grams? If 1 mole has CH4, 16.043 grams. So I do 10.4 divided by 16.043. 0.64826, 5 sig figs, right? 2 extras on that. So this guy's going to be 0.64826, right? Because we times it by 2 divided by 2. Last step. How many grams are there in 0.64826 moles? If there are 50.488 grams in 1 mole. So we take our answer, multiply it by 50.488, 32.7 grams. Now over here we can do our percent yield. It's equal to our actual amount divided by our theoretical. Our actual amount was 10 grams. We're going to pretend that's 2 sig figs. Divided by 32.7 grams. So we do 10 divided by this number. And we get 0.31 with 2 significant figures, or 31% yield. There we go. Done. That is question number 6. Ooh, 33 minutes for me to take to do all of these. It's a lot of work. There's question number 6. The amount, the percent yield. There's question number 5. The amount, the percent yield. There's question number 4. The amount, the theoretical amount, the actual amount. There's question number 3. Theoretical amount after limiting reagents, percent yield. Question number 2. Theoretical amount, percent yield. Question number 1. Theoretical amount, excess amount. All right. I hope you can get these questions. I hope the way I laid it out for you is really helpful. And thank you for watching.